All right, looking at the next section here, we have sections B and C, converting polar coordinates to rectangular and going the other way around also. Let's start with these, converting polar to rectangular. I am not going to give you these formulas. You need to memorize these. That is a horrible penmanship, but whatever. Or digitalmanship. It's not really a pen. Not quite sure what to call this. All right. So here we have an r and a theta, and if we're going from polar to rectangular, I need to convert r and theta. I need to go from r theta to xy. That's what rectangular means. Well, going from r theta to xy is to me a lot easier than the other way around because we have these two nice convenient conversions right here. X equals r cosine theta and y equals r sine. So x is going to equal r cosine, which will be 3 cosine pi over 3. And on the unit circle, let's see, cosine pi over 3, my cosine is 1/2. So x is going to equal 3 times 1/2, which is 3/2. So there's my x coordinate. And then my y coordinate is going to equal r times the sine of pi over 3. And the sine of pi over 3, see my coordinates there are 1/2 root 3 over 2. And the sine is root 3 over 2. So y is going to equal 3 times root 3 over 2. You can't really multiply that, so we'll just call it 3 root 3 over 2 for the y coordinate. And then I do want you to actually list it as an ordered pair, so 3/2 and 3 root 3 over 2. There we go. Simply plug into these formulas over there. Number 7, x equals -4 cosine of the angle, 5 pi over 3. And y is going to equal -4 times the sine of 5 pi over 3. 5 pi over 3 is down here, and the coordinates there, your x is positive 1/2 and your y is negative root 3 over 2. And we'll simply plug those in. So -4 times cosine is 1/2. Half of -4 is -2, so there's my x. Y is -4, sine is negative root 3 over 2. And that's going to clean up. 2 goes into 4 twice. So it's going to be positive 2 root 3. It's going to equal my y. And I get an answer of -2 and 2 pi over 3. Or not 2 pi over 3, 2 root 3. Good, 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 good. Simple stuff, I think. I think this is kind of nice. You're free to disagree with me. I don't like you anyway. Ah, geez, why did I do that? Negative root 2 and 2 root 3. Okay, here. I wanted that. Well, that's kind of ugly. All right. This one, 3 pi. X is equal to 3 times the cosine of pi. And y equals 3 times the sine of pi. So I got to think about my unit circle. Pi is right here. And the coordinates are, I went left 1. I didn't go up or down. So x is going to equal 3 times cosine of pi is -1. And that's -3. Y is going to equal 3 times the sine of pi, which is 0. And so you get an answer of -3, 0. So there is converting polar to rectangular. You simply throw it into x equals r cosine and y equals r sine, and there you go. Going in the other direction is a little bit trickier because here we have x's and y's, and to go from xy to r theta can be a little tougher. So let's look at this one. If x is 4 and y is 0, I'm actually going to start with this formula right here because that's going to tell me my r. So x squared plus y squared equals r squared. So 4 squared plus 0 squared is equal to r squared. You know what? I'm not going to use that one. That would work. I'm going to take out one step. I need r, not r squared. So actually, let's use this one. Let's use r equals the square root of x squared plus y squared. So r is equal to the square root of x squared plus y squared. So r is going to equal the square root of 16 plus 0. The square root of 16 is 4. So there's my r. And now I need my angle. And to get the angle, you could use a whole bunch of different things. It really doesn't matter which one you choose. I prefer this one. I prefer that. So I'm going to use x equals r cosine theta. I know that x is 4, so 4 is equal to, I know my r is 4. cosine theta. I'm simply plugging in to the equation x equals r cosine theta. I will divide by 4 to get cosine by itself. So 1 is equal to the cosine of theta. And cosine theta equals 1 at an angle of 0. Um, and so I do want to do this. I'm going to plot the point 4, 0. That means I go out to the right 4 units and I don't go up or down. And this one's kind of nice because you can actually just look at that and tell that you're going straight right, which is an angle of 0 degrees or 0 radians. And so an angle of 0 makes sense. So I have my angle, I have my r, and then just like the last questions where we were going to rectangular form, I want you to actually write it in polar form, which is r theta. Now this is kind of a silly problem because when you convert it, it looks the exact same, but it's read slightly different because this is now a distance and that's an angle, whereas this one was an x and that's a y. It's the only time that your polar and rectangulars are going to look the same. Let's see, number 10, same thing. I'm going to find my r. R is equal to the square root of 2 squared plus negative 2. Make sure you watch your signs there. When you square negative 2, actually, let's just put everything in parentheses to avoid the mistake. When you square negative 2, you actually do get a positive number. 2 squared is 4. Negative 2 squared is also 4. 4 plus 4 is 8. And 8 simplifies to 2 square root of 2. There's my r. So I'll kind of put that on hold for a minute. And then I need to find my angle. So I know that x equals r cosine theta. I know that my x coordinate is 2. My r is 2 square root of 2. Cosine theta will divide by 2 root 2. And the 2's cancel, giving you 1 over the square root of 2 is equal to cosine theta. That may not look familiar to you because y'all are determined to rationalize everything. So if we did rationalize this, multiply top and bottom by root 2, 1 times root 2 is the square root of 2. Root 2 times root 2 is 2. And we get root 2 over 2 is equal to cosine theta. That happens in 2 places. That happens at pi over 4. And if you punch this in the calculator, that's what your calculator is going to tell you. It also happens, though, if you think about cosine being positive, it happens up here. It also happens at this angle down here, which is 7 pi over 4 in the 4th quadrant. And you need to be aware of both of those, because if you were to plot the point 2, negative 2, you would go right 2, you would go down 2. That point is in the 4th quadrant, so we need to make sure we choose the angle that's in the 4th quadrant. Your calculator is not going to tell you 7 pi over 4. It's only going to give you the pi over 4. So you have to think above the calculator to choose the correct one. That's in the 4th quadrant. And there's my angle. So my answer is going to be my r of 2 root 2 and an angle of 7 pi over 4. Good, good? Good, good. Let's see, number 11. Starting off the same way, r is equal to the square root of x squared plus y squared. R equals the square root of 1 squared is 1, root 3 squared is 3, 1 plus 3 is 4, the square root of 4 is 2. So there's my r. And I need to get my angle, so I'm going to start with x equals r cosine theta. And x is negative 1. We just found out my r is 2. We'll divide by 2. You get negative 1/2 equals cosine theta. And again, look at my unit circle. That happens up here at 2 pi over 3. It also happens down here at 4 pi over 3. So we have these two angles. So we get 2 pi over 3 and 4 pi over 3. And we need to make sure we choose the angle that is in the correct quadrant. So I plot the point negative 1, positive root 3. Not sure exactly where positive root 3 is, but I know it's in the 2nd quadrant, right? And so I choose the angle that's in the 2nd quadrant. We're going to stick with 2 pi over 3, not 4 pi over 3. That one is in the 2nd quadrant. So make sure you choose the correct angle. And then once you have your r and your theta, we'll write it in r theta form to 2 pi over 3. Good, good? Good, good. Now let's see, is that all of it for this one? I think it is. Yeah. All right, so there is converting points from full to rectangular and vice versa.